Up next, we have Akhil Mohan, a software engineer at VMware by Broadcom. Akhil specializes in optimizing container environments, which is crucial for enhancing AI deployments. Akhil will be presenting on improving container startup time using stargz. In this session, he will introduce stargz snapshotter and the estargz image format, focusing on lazy image loading to reduce container startup times, specifically in Kubernetes and Docker environments, an essential topic for anyone dealing with efficient AI deployments. Let's welcome Akhil Mohan.
Good afternoon, all. So, uh, I'm mostly working on containers at VMware, and also I'm a maintainer of containerd in the open source. So, I'll be talking about improving the container startup time using stargz format. So, first, let's just get into the basics of what happens when you start a container. So this mostly about starting a container on a node or on a cold node that doesn't have any images currently loaded. So it will involve, like, first you have to pull the image from the registry, then you have to create the file system that actually is used by the container process, and then you have to run the container process. Now let's dig in a little deeper into how exactly this happens. So we will go into how the pull and the extracting of the image layer works. So basically, if you're using a client like Docker or netctl, initially a get manifest call will be made to the registry, and when you want to do a Docker pull, and this will give you a manifest file. So this manifest file actually has data about all the layers in the image that you want to pull. Then for each layer that you want to pull, again a get request is made to the registry, and each of these layers are pulled and then stored locally. So once all the layers are in, now we need to extract and perform an operation called like preparing a snapshot. So now for each layer that we have like fetched, we call the prepare snapshot call, which basically extracts each layer and then mounts one layer on top of another, and finally creates a committed snapshot, which is a read-only file system for your container. And that's basically like the complete pull and extract process. So in all this process that we discussed previously, which costs the most amount of time. So pulling image is actually taking up the most amount of time. So this has been like from a benchmark that was been done by containerd. So on some of the most commonly used images. So this is like for the GCC image and the Python 3.7. So basically you can see that the pull is taking the maximum amount of time, run and create are like very little. So if you compare the startup time of containers, so 76% of the container startup time is like into pulling the images. And again, this is like only on a cold node where the image is not present currently. The other thing is like you pull the complete image, but less than 10% of the content of the image is like actually immediately needed. So like you pull the complete GCC image, but like only like a few libraries or few binaries will be actually needed. So when you pull large images, it's like actually easily noticeable, like that we are losing so much time in pulling the images. So this data is actually from a survey that was like done a few years back from Usenix. So now let's dig into another concept called like snapshotter. So this is like kind of a basic thing that you need to know, like before getting into the stargz part. So in containerd, like containerd actually forms the backend of Docker. So a snapshotter actually creates the root file system that is needed for running your container process. So a snapshotter basically creates the file system for the container, and so mounts each layer and then creates a read-only snapshot. And once you run the container process, what really happens is an active snapshot is created, which is basically a read-write file system that is based on top of the committed snapshot. So all the writes that happen inside your container will be basically done in the active snapshot. So Containerd basically supports two types of snapshotter. One is local snapshotter and the other is remote snapshotter. A local snapshotter is the one in which like you need to have all the content present locally on your host machine. And in case of a remote snapshotter, it's not necessary that all the content is present. So the content can be like somewhere in a registry or in a remote location. So the remote snapshotter is something that we are using to improve the startup time. So now let's get into stargz. So stargz is basically a seekable targz format. So this was like it's a format for transferring and like storing the container images, and it's based on Google CRFS, which is a container registry file system that Google has developed. So now let's get into how targz really works. So a simple targz file is like a gzip of all the and a gzip, and then you have the tar archive of all the files combined in that. So one disadvantage with this is that like a tar file is actually not like seekable. So you, even if you want to just access one file in a tar archive or a zip archive, you have to actually extract the complete archive and then get to it. So stargz basically solves this by like making the individual files will be like tar gzipped, and then you concatenate the gzip files. So what actually enables to do this is if there is a simple thing in like gzip that if you combine two gzip streams together, the resultant gzip will also be like still a valid gzip stream. So that basic principle is being used here. So I have provided reference for the Google CRFS also. So now let's get into the estargz. So estargz is basically the extended version of stargz that was created. So this is the structure of the stargz header, stargz blob. So the only part that you have to concern about is like the TOC part, which is like a table of contents. So the TOC actually helps with indexing and seeking inside a blob. So so the advantages that like estargz provides along with stargz are like for each of the chunks you can have individual content verification and also like content prefetch. So if you just need like 2-3 files out of a complete RRK, you can just fetch and extract only those 2-3 files and keep it locally, and the rest of them will remain in the registry itself. So that's how like the estargz also helps with the content verification that is basically done by the TOC storing the digest of each of the files or the chunks of data. So either the estargz either compresses individual files, or in case of like large files, it splits the file into multiple chunks and then stores the index of that. So now let's get into like how stargz snapshotter works. So combining the estargz format and the snapshotter from Containerd, like Containerd team has developed a snapshotter called stargz snapshotter. So earlier we saw that like we download each layer and then like prepare the file system and mounts it over. But in case of the stargz snapshotter, to mount the snapshot, you actually don't need all the files. Like basically the files can reside in the registry and the snapshotter will still say that like a committed snapshot is available. The content of all the file that you want to get or like is needed is actually present in the TOC. So whenever the container runtime needs to access a file, it goes to the TOC, gets the index of the file, and then downloads it from the registry, and all of this happens during runtime. This is like the GitHub URL for the Containerd stargz snapshotter. And these were the improvements in time that we saw when we were using like stargz instead of the legacy overlay of a snapshotter that containerd or Docker uses by default. So for the GCC and Python 3.7 images, we were seeing like a lot of the pull time has been like reduced by a lot. And this benchmark is like continuously done on the stargz repo, so we know at any point of time what is the current results that are produced by the stargz snapshotter. Now we will get over with the theory and see how you can really use it in your environment. So to build a stargz image, like instead of the normal images that you build using like Docker build, you need to create a build kit builder that basically uses a containerd worker snapshotter. And so you create a new builder and then like bootstrap the builder. So now I'm going to build a simple program, a simple container image from a Ubuntu 22.04 Docker image. So this I'm using the netctl client. So this like it's a binary that has been developed by the containerd team so to experiment with new features in containerd itself. So here you can see that like the compression is like provided as stargz, and the rest of the commands are same as you expect in like a normal Docker build command. So one additional thing that you need to follow is like we need to provide a force compression flag is equal to true. So this is done so that the Ubuntu 22.04 image that is available in the container registry is not a stargz formatted image. So when you give a force compression, it basically recompresses all the layers in the image. So if you don't provide the force compression flag, what actually happens is only the run and copy, only those two layers will be in the stargz format. The initial one will be like still in the old targzip format. So you won't get the expected the results as expected. So when you provide the force compression, all the layers will be like recompressed and then the image will be created. So this is like the, okay, I think the font is small. Final image that is like created, and you can see that there are additional annotations for the stargz digest and like the stargz compress size. So now if you want to build another image with, that uses another stargz image as the base image. In that case, you need to enable something called as containerd, the snapshotter that we mentioned previously in containerd plugins. So this is from the containerd config.toml file. So if you work with like Docker or containerd, you know that like there is already a config file that is present, and you can basically enable the stargz snapshotter plugin. And from the, once you enable it, all the stargz files will be handled by the stargz snapshotter. And now I'm going to use the image that I had built previously from the Ubuntu base image, and then on top of that I am adding like 2 more layers and then building it. So in this case the build will be like actually very fast because the initial image is also a stargz image, and like I am not using any layers from that one. So the build will happen very fastly because I don't want to pull any other layers. Now when you are running a container also, you can see this difference. So the image I built in the previous case is now like run. So only the layers, so for example, the entry point like we had given as a hello.sh script. So only those, what is needed to run that bash script will be pulled, and then it will be run. So the other components that were present in the Ubuntu base image, or none of them will be pulled. But like the runtime will have a, will be seeing that the complete image is there, but the snapshotter handles that case and says only pulls whatever is necessary. So when to use the stargz snapshotter in your environment? So if you have CI systems where the VMs are spawned and then you have to download all the container images, then you can use this. So the stargz format was initially invented at Google because for the Golang team, when they were doing testing, so for every single commit, they had to create a new VM and then the complete testing was done. So this was causing a huge delay for them in like their development. That's why this CRFS and the stargz format was invented, so that they need to download only the necessary files to compile it. Another use case is like whenever a new node comes up in a cluster and you have to download like large images, mostly like the image size of like AI workloads will be like very huge. In that case, you can use stargz snapshotter, and again this is in the case of like cold VMs. And there are also a few other projects from other companies and containerd that also makes use of like lazy pulling or like the seekable format. One is the Sochi, that is like seekable OCI developed from AWS, that is like compared to the stargz format. But for this, you need a support from the OCI registry also. The advantage of using stargz is like your existing registry can work as is and then provide you the stargz image. Another is a NIDA snapshotter. This is a project from containerd itself. This is similar to stargz, but one more feature on top of it is like the P2P file sharing on top of the stargz snapshotter. So instead of pulling the images from the registry, if there are some machines in your network or like cluster that already has the images, you can share the files from there and then run it. So that's about it. And if anyone of you have questions.
Any questions so far?
Is it compatible with the CRIO?
Yes. So for CRIO, instead of the snapshotter, there is a stargz store that is underneath the stargz snapshotter. You only have to install that. You don't need to install the stargz snapshotter also. So it's present in the same repo as the stargz snapshotter. You need to only install that. Then like Podman and CRIO can make use of it.
Thank you.
There are already examples in the repo to make in that way. Yeah.
So you mentioned that once the initial piece is downloaded, then rest of the things are being downloaded in runtime, right?
Yes.
So that would increase the network delay, right? If there are.
Yes. So that is like actually it increases, but in the benchmark test that we have seen, that was much lesser than the complete pull time that we spend like while pulling all the images.
Entire thing.
Entire layers. So the runtime, while running or creating, you may see sometimes the delay will be more, but like that is compensated by the reduced pull time.
Okay.
Yeah.
That answers.
Thank you, Akhil, for the insightful talk. Now let's welcome Srijit to hand over a token of appreciation.